In this example of partial fractions, we're going to deal with one that's a combination of a type 2 one where we have a repeated factor, and it's also got one of them which is an irreducible quadratic factor. So we're going to look at this example here where we have to express in partial fractions 3x plus 4 over x squared times x squared plus 1. So this is a good deal harder than the ones we've done up to now. And even just getting the stats a little bit more tricky, but we'll just go through it step by step. First of all, the x squared, it needs to split up into two bits. We've got the x term on the denominator and then an x squared term. And that's a on the top and b on the top. And then we've got the irreducible quadratic term coming up next, the x squared plus 1. So that gives us a term with a cx plus d on the top. So in this example, we've got 4 letters to figure out. As before, we start off by multiplying through by the denominator, x squared times x squared plus 1. So when we do that, on the left-hand side, multiplying through by the denominator, of course, just gets rid of this denominator, cancel out, leaving us 3x plus 4. And then dealing with the a term next, if we multiply this bit through by this denominator, this x on the bottom is going to cancel out one of the x squared at the beginning, so we're left with a times x squared plus 1 in brackets. Then if we look at the b term, because we have an x squared on the bottom here, it's going to be cancelled out by this x squared here, leaving us b times x squared plus 1. And then the cx plus d term, when we multiply it through by the denominator, the x squared plus 1s are going to cancel out, just leaving us with the x squared. And remember, of course, that you need to put the cx plus d term in brackets. Now, in this example here, we're a little bit limited in values we can choose for x. So we're actually going to look at a slightly different method to dealing with this one. We're going to start off by letting x equal 0, however, because if we do that, then that will allow us to get rid of the a term, because of that x there, and allow us to get rid of the c term and the d term, because we've got an x squared at the end of that one as well. So in effect, we're just going to be left with this b term. We're replacing x with 0, so we're going to get rid of everything apart from the b, and of course the left hand side here, when we replace x with 0 here, we get a 4, and that just becomes b on the right hand side. Nothing plus 1. It just gives us 1b. Now at this point, if you look through it, there isn't really any obvious letters we can choose to replace x with that would allow us to make much progress. If we pick -1, for example, when we square it, isn't going to be very helpful here. So we need to tackle it slightly differently. And the method we're going to use is we're going to look to equate the coefficients of each term. There's a little step in here just to try and make that easier to do, just multiplying out this stuff. So when we do that, the a term becomes a times x cubed plus x. I've just multiplied these brackets. The b term doesn't change. And here, if I multiply through by the x squared, I get cx cubed plus dx squared. And that'll just make the next bits easier to spot the coefficients. So looking at it here, we've got our x coefficient we'll deal with first. So on the left hand side, the coefficient of x is a 3. Going through this, we have an x term here, so that'll give us an a. Looking at this one here, that isn't an x term, and looking at this part here, that isn't an x term either, so we just end up with 3 equals a. So we figured out that a equals 3. Then we can deal with the x squared terms. Looking at the left hand side, there isn't an x squared term, so we just need to put a 0 in there. And looking at the right hand side, there's no x squared attached to the a. The b term here has got an x squared, so that gives us a b, and of course the d has got an x squared term with it, which gives us b plus d. Those are the two coefficients of the x squared part. Of course, we've already figured out that b is equal to 4, which allows us to figure out d. In this case, it's minus 4. So we've figured out what a is, we've figured out what b is, and we've figured out what d is. Just leaving us c. So at this point, you could substitute any number you like into it, to be honest, because since you know a, b, and d, we can get an answer regardless of what we do. But if we just stick to the method of equating coefficients, on the left-hand side, the coefficient of x cubed is 0. On the right-hand side, we've got an x cubed term here, no x cubed term here, and we've got a c x cubed term, which gives us a plus c as the coefficients of x cubed. We've already figured out that a is equal to 3, which leads us to a value of minus 3 for c. Which leaves us just to finish off our answer. So 3x plus 4 over x squared times x squared plus 1 becomes 3 over x plus 4 over x squared minus 3x plus 4. And you'll notice again, as I did in a previous example, just to tidy it up a little bit, I've taken the minus out of this, minus 3 and minus 4 values for c and d, and made them positive but put the minus there. And you've got to be careful when you're doing that, just to make sure you don't get the sign here wrong. And that's the example completed.